Hello, this is the Fnirsi FNB58 USB fast charge tester. And you can see here that it does volts to 5 decimal places, also amps and watts, also temperature there. But it does a lot more besides, so let's go through it. I might have to work quite quickly because there's a lot to go through. Okay, unboxing. Here it is. I'll take it out of its box. And also there's a little LCD cover there. Let's power the device up from a power bank. This is one of the newest power banks I've got. And you can see there the first screen, which is voltage, current, and you've got a direction arrow for the current as well, and watts and also temperature. Now, before I go on to any of the other screens, I think I'm going to do inputs and outputs, the navigation system, connectivity. USB type A. Now this is a 5-pin male plug. There's also a USB type A socket at the back here. There are 2 USB type Cs. These are 24-pin. This one's called input and this one's called output. And there's a switch here that switches on and off the power delivery COM signal. There's also an input here which is micro USB type micro B. Now on the top there's another micro B USB, but this is for connecting to a PC to run the PC software. Also you can use this to power this device, so if you're doing something where you don't want this to power off while you're changing input and output sockets, and we'll come back to that, then you can use this to keep it powered. Here's the navigation system. You can press the wheel button down in the middle there as a sort of OK function. There's a back function, and then there's left and right on the wheel. And actually this navigation system works quite well. Little blue LED in there. Is that everything covered? Yes, I believe it is. Oh, apart from there is a Bluetooth module on the back here, so they've cut a hole in the metal case for the Bluetooth RF signal, and you can use this in conjunction with an app which you can install on a phone. Now on this first screen you've got run and pause. So if you pause, if you press the button in, you can pause, red light comes on, or run. So this is continual updating in that screen. Okay, let's move to the next screen. Similar, you've also got volts, amps and watts, but now we've got additional information. We've got the voltages on D- and D+. We've also got some decoding of what it's seeing on D- and D+, so we can see that we've got dedicated charging port 1.5 amp and also Apple 2.4 amp. Now there are 10 memories and you can do data logging. So you've got the energy statistics here in memory 1 of those 10 with time, capacity in amp hours, and energy, accumulated energy in watt hours. The next screen is an oscilloscope, and there are various modes here. So we can see here the voltage to 5 decimal places again, and we've got current. There isn't any current because there's nothing plugged into the back. Now this shows us the key frequency, which it's showing, well, it's darting about, but it's around 100 kilohertz, and also the peak-to-peak noise, which it's showing at about 40 millivolts. There is a time base indicator here, 20 microseconds per division. Now to change this you have to rock and hold, and then that will change to 10 microseconds per division, 5 microseconds per division, and 2.5 is the fastest. This also has run and pause by pressing the button in like so, and if you hold the button in you change to a different mode. This is more of a data logging mode. Voltage and current are both logged, and we can change the time base from 0.1 seconds per division. It says limited, so that's right up at one end. And you've got to do this rock and hold. One thing I've noticed is if you let this time out and the screen goes dim, it does respond to presses and single movements of this rocker, which here would just take us into another screen, but it doesn't respond to rock and hold. So you've got to get out of the dim mode, probably by using the back button or something like that, and then you can reuse the rock and hold. So data logging goes all the way down to 5 seconds per division, and that's the limit. Press and hold this rocker again, and we get into logging of the D plus and D minus signals. Again, probably we can change the time base. Yes, 0.2 seconds per division, 0.5, so that you can see what is happening to those signals if some sort of communication is going on. And then the fourth screen after oscilloscope is an applications menu with fast charge options, statistics options, a toolbox of other functions, and a settings screen. If we go into that, you can see we can set things such as display brightness, standby brightness, the time it takes to go into standby brightness, refresh rate, settings for recordings, trigger settings, system settings, restore factory defaults, and an about, which tells you the firmware and other information. So the navigation, you can use the back button to come out of a function like this. I don't think I can come out of that, no. So those are the four screens. I'll just go through them again. Okay, now if we go into fast charge and press this button, it gives you a warning. Now this is because what it's going to do in this mode is try and trigger all the fast charge protocols in sequence and then list them to show you what's available. So you don't want anything connected on the output because that could get up to 20 volts. So definitely don't want a phone or something like that on there, but even a little LED light, you'd probably blow it. Okay, so we'll go into that. Now we can do automatic detection of PD and other protocols, so quick charge and all the exotic ones. We've got PD trigger, so that we can trigger from power delivery the higher voltages like 9 volts, 12 volts, 15 volts and 20 volts. And QC 2.0, Qualcomm fast charge, and QC3. Okay, in statistics, we have energy statistics, battery capacity calculations, so you can test the capacity of batteries, power banks, I suppose, specifically, and offline recording. You can view your offline recording curves. There must be a fair bit of memory in here. In the toolbox, we've got cable resistance detection. I will go into this in some detail, so you can measure the resistance of USB cables. You've got a PD listener, which means that you can look at the communication signals between a power bank and another device to see what's happening on the PD control signals. PD converter, probably won't go into that. USB-C E-marker, it can tell you whether your USB Type-C cable has an E-marker chip. That's the chip which tells devices either end of the cable that you can use 5 amps rather than the standard 3. Right, let's look at some specific things. So I'm going to press the back button to come out of here, and I need to rock across. I'm going to do the oscilloscope because I found a power bank which has quite an interesting output, so let's get that. This is the power bank. I'm not going to show the brand name because I'm not trying to diss any particular brand, but this one does have an interesting effect. The other thing is the connector here just doesn't seem to mate very well with this, and if you push it all the way in, it just doesn't seem to connect. So I'll run it at the end of this short extension lead. Okay, let's switch that on and take a look at the oscilloscope, and yes, we've got quite an interesting curve here with a very interesting frequency. This is actually showing a frequency, I'm going to have to rock this to fit more on, at 10, let's say 20 microseconds per division, but we've got a very low frequency. I mean, that's in the audio range. This is showing around about 7 kilohertz, and the peak-to-peak noise on the 5 volt output is actually half a volt. It's absolutely enormous. Now, what if I load that down with a constant current electronic DC load? That's on minimum. You can see the current there is very little. As I increase the load current, then you can see that the frequency of the converter electronics in this unit is changing. And now I can rock and hold this rocker. Let's go back the other way. Oh, I might be in the dim mode. I am in the dim mode, and that's where rock and hold doesn't seem to be actioned, so you need to come out of the dim mode by pressing any button, I think it is, but the back button is convenient. So here the frequency is increased to around 30 kilohertz, so that's no longer audible, but we've still got 460 millivolts of noise. Let's start increasing the load up to half an amp there, so the frequency is changing, and the more I increase the load, the faster the frequency gets. We're up to 100 kilohertz now, so I can rock and hold to get more detail on that. That's the fastest, 2.5 microseconds per division. Let's go back to 5 microseconds per division. And yeah, this power bank was just interesting because it just had a lot of oscillation on the 5-volt output. Right, I want to change the supply power now, but I don't want to lose the oscilloscope function. So what I'm going to do, I've got another USB converter here from a power tool battery. I'm going to plug that into this top USB type B port. That means I can take off the input device, but I've still got this thing powered up. Now I can go to another USB power bank and then take a look at the difference on that one. Again, I've got an approximate 1 amp load. This fan has started up and that's getting quite warm now. And you can see that this has got a very different amount of peak to peak noise and at a different frequency. So once again, I can work through the time base to get a bit more detail on that. That's the best I can do, but this has only got 50 millivolts of 5-volt noise. Right, so that's the oscilloscope. Now let's move on to the applications. Let's go into fast charge. We get the warning that this menu can trigger high voltages on the output, but we'll go into that. So let's do an automatic detection of all the protocols that this fairly modern power bank can offer. So this just goes into a detection routine. No PD because we're on the USB type A socket, but we have got Apple. Let's try it again with this switched on, and I can just press that and run that again and see what it comes up with. Okay, Apple dedicated charging port. Now we've got Samsung 9 volts. We've got Huawei 12 volts. We've got QC type 2 12 volts. We've also got QC3 12 volts. So 12 volts would have appeared on the back end there. This one also has PE plus 1.1 and PE plus 2.0, whatever they are. Okay, let's compare that with this old power bank, which I do believe has QC2 but not QC3. So let's run this routine again. Yeah, that should have triggered QC2. Maybe this one's switched off. I'll switch that on. No Huawei. Yes, it's detected QC2 up to 12 volts, but no QC3. And I do know that this is a QC2 only power bank. So far less functionality on this older power bank than on this newer one. Right, let's go into the next function, which is PD trigger. So we can trigger the different modes in power delivery. Now it says failed to detect PD charger, and that's because you have to switch on this PD COM signal. Okay, so here we've got all the PD modes available from this device, and they are 5 volt 2 amps, and we can now switch between them. And you will notice I've now triggered 9 volts. So we're actually getting 9 volts on this cable. So there would be 9 volts on the USB type C out and presumably on the type A out. And I can also trigger 12 volts 1.5 amps. Right, let's take the USB type C cable out of that power bank, and I've got a power station here which has a PD 100 watt output on it, and you can see that this one triggers more modes. We've got 5 volts, we can go into 9 volts, 12 volts, we've also got 15 and 20 volts, and they're all showing up here on the voltmeter. There's also this one which is a 3.3 to 16 volt at 3 amps mode, and there's also a 3.3 volts to 21 volts at 3 amps mode, and presumably if I press this button I can now move the voltage in increments of 100 millivolts. Right, in the application screen we've now got the toolbox, so let's go into that, and we get to cable resistance detection. So for cable resistance detection, you need to take a reference value with no cable. Now the only way I can see of doing that is to plug the Type A plug into USB. We need voltage and current, so I'm going to have to put my DC load in here. And the manual says set the DC load to somewhere between half an amp and 1 amp. So let's do it at 0.75 amps, something like that. So we've got a voltage and current reading. Now we press the button to take a reference. Oh, that just brightened it up. So we got the reference values in this box here. Now we introduce the cable. So I'll pull this out, and that's where it's useful to have it powered up separately. And I'm going to test this horrible Type A to Type C cable, which came with a little cheap torch thing, and it has a really poor resistance. So Type C, I have to plug it into here. Now, yes, we are using a different connector, and the connector resistances are going to be slightly different, but there's not much I can do about that. And you can see here that the real time voltage and current, and we've got the same load, are giving me a value of 1.6 ohms. So this very short cable has a resistance of 1.6 ohms, calculated from the fact that we've got a huge voltage drop. So the reference voltage was 5.2 volts. We're now only seeing 3.9 at this input port. The current is the same because this is a constant current load. It's still pulling 0.75 amps even at that lower voltage. So for this function you do need to use a constant current, one of these adjustable constant current loads. So let's compare this cable with another Type A to Type C cable, and the Type C into here. We can use the same reference information because that's with no cable, and this one is better. It's 350 milliohms, and you can see that the voltage is considerably higher, 4.9 volts, and we've got the same current, 0.75 amps. Okay, let's come out of that test, and now we'll go into, well, let's do the USB Type C E marker test, and that's going to look for the E marker chip in a USB Type C cable. So I have two USB Type C to Type C cables here. The blue one, or the green one, is a standard 3 amp, so it doesn't have an E marker chip. If you want a cable to indicate to the two devices either side of it that the cable is good for 5 amps, then it does need an E marker chip. So let's plug in the 3 amp cable without an E marker. You do need the little PD-COM switch on for doing this. Now it seems that you can plug this in either socket, and you can see that it doesn't find the E marker chip because that cable doesn't have one. However, if I plug in this cable, which does have an E marker chip, you can see immediately it's able to read that chip, and you've got all sorts of information here. Vendor ID, it's not in there. Passive, USB 3.2 Gen 2. Length is 0 to 1 meter. Oh, that's interesting. I wonder if I've got a 5 amp cable that's longer than 1 meter. Maximum voltage 20 volts, maximum current 5 amps, and no hardware and firmware codes in there. And it seems you can plug this cable into either socket and get that information up. And can you connect it either end? Yes, it seems that the chip is readable in either socket and either end of this 5 amp cable. Okay, finally let's go into PD Listener, and this is where it will just show you stuff related to PD protocol. And I'm going to put a power bank in one socket, and I don't know, another power bank perhaps in the other socket. Right, let's use the PD listener between this X-Tar power bank and my RAV power bank. And if I plug in the RAV power, then we should get the capabilities. Now I think it's, yes, that says in. So the RAV power is the source, and it has these 5 different voltage ratings, 5 volts up to 20 volts. And you can see if you press the OK button source and sync information on the PD listener. Now if I press and hold the RAV Power's power button and hold it for 10 seconds, it actually changes direction, and now the X-tar is the source. You can see that it's saying out, so it can provide these three voltages, 5, 9 and 12, and it says it's a maximum 18 watt power bank. And then if I change direction again to make the RAV Power the source, once again we can now see that it's a maximum 60 watt power bank, which it has a 60 watt output. It's currently using the 12 volt option because the X-tar only goes up to 12 volts, but it does have these 5 voltage options. So that was a little look at the Fnirsi FNB58 USB tester. Huge amount of functionality on this thing. My knowledge of USB, and particularly USB Type-C, probably isn't sufficient to cover everything in complete detail, but I hope that overview gave you just an introduction to what this device can do. So purchase links will be in the description below this video, but that's it for now, so cheerio.